Assalamualaikum warahmatullahi wabarakatuh. We are from JCDCS1342E. We're presenting our group project under MAT183, which is differentiation. Here are our members.
Differentiation is a process finding the derivative or rate of change of a function. In contrast to the absurd nature of the theory behind it, the practical technique of differentiation can be carried out by using algebra manipulation, using 3 derivatives, 4 rules of the operation, and a knowledge of how to manipulate functions.
Before we move further, we will look at the techniques of differentiation. The first technique is of the power rule. The formula that will be used is fx equal to x to the power of n, then f prime x equal to nx to the power of n minus 1. This will apply to any real number with n. For example, if fx equal to 2x to the power of negative 10, therefore f prime x equal to negative 10 times 2x to the power of negative 10 minus 1. And the final answer that we will get is negative 20x. Now we will go look at the constant rule. For the constant rule, the formula that we'll be using is if fx equal to c, where c is a constant, then f prime x equal to 0. If you look at the graph, y equal to 6. Therefore, the tangent line to the graph of fx equal to c has slope 0 for all x.
The third technique in differentiation is sums and difference rule. In this technique, we have to differentiate each part of the numbers, as the example shows. The fourth technique of differentiation is the product rule. In this technique, it is easier to use the uv prime plus vu prime formula. In this example, we use u as 4x squared minus 1, v as 7x cubed plus x, u prime as 8x, v prime as 21x squared plus 1.
Technique is quotient rule. Formula for quotient rule is vu prime minus uv prime over v squared. The numerator will be u and the denominator will be v. We will differentiate both u and v to get u prime and v prime, and then substitute the value into the formula given. Next, chain rule. For the chain rule, this technique will use for finding the derivative of composite function. In this rule, have a two case. Case 1, if fx equal g hx, then f prime equal g prime hx times h prime x. Case 2, if y equal fu and u equal gx, then dy over dx equal dy over du times du over dx. For this example, we use case 2. So, if y equal cos x cubed, and then let u equal x cubed, and express y as y equal cos u. Use the formula dy over dx equal dy over du times du over dx. dy over du means differentiate for y, and then du over dx differentiate for u. Then calculate, and we will get the final answer, negative 3x squared sine x cubed. Is local linear approximation differentiation. Okay, how to use? To estimate the value of a function near a no point using its tangent line, and how to use, just apply the formula fx approx fx naught plus f prime f naught f minus f naught using the function value and derivative at x naught. And we already attached the example of this technique. Okay, last technique of this differentiation is implicate differentiation, used when functions are not explicitly solved for y in terms of x. Method differentiate both sides with respect to x, treating y as a function of x, and we need to multiply x in both sides, and we need to make dy over dx as the subject. Question 2a, and the question is y equal e over 2x sine x plus 2. We use formula u
v prime plus v u prime. And like you see, we already differentiate the value, and we just need to put that value in your formula. Okay, dy over dx equal e power 2x times cos x plus 2 and plus sin x plus 2 times 2e power 2x. The last step is summarize the answer. Okay, here we go. Dy over dx equal e power 2x cos x plus 2 plus 2e power 2x sin x plus 2.
Question 2b asks us to find the dy over dx for the following function, which is w equal to 4x plus 2 over ln x. In this function, we use the quotient rule. 4x plus 2 as u and ln x as v. Then, we can sub each value in the formula vu prime minus uv prime over v square. U prime is the differentiation of 4x plus 2, which is equal to 4, and v prime is the differentiation of ln x, which is equal to 1 over x. After we sub each value, we can calculate and get the answer dy over dx equal to 4x ln x minus 4x plus 2 over x ln x squared.
Now, to solve question 3, we have to use the implicit differentiation. For implicit differentiation, we have to make sure that we have d over dx in front of all of our equation. For example, d over dx in bracket e to the power of y square minus 4 minus d over dx in bracket x over y cube equal to d over dx in bracket 1 minus d over dx in bracket negative cos 5x. Then we have to differentiate all of it. If we differentiate x over y cube, we have to use the quotient rule, which is vu prime minus uv prime over v squared. Now, we will get the answer after differentiate is dye to the power of y square minus 4 dy over dx minus y cube negative 3xy square dy over dx over y to the power of 6 equal to 5 sin 5x. Now, we have to multiply all of the equations with y to the power of 6 to delete the denominator. Therefore, we have to factorize dy over dx to make sure it was the main topic for this equation. Then, the final answer that we will get is dy over dx equal to 5 sin 5x plus y over dy e to the power of y squared minus 4 plus 3x.
For this question, we use formula linear approximation. The formula is f x naught plus delta x approximate f x naught plus f prime x naught times delta x. So, let fx equal 4 root of x minus x over 4 squared. Then simplify x power of 1 over 4 minus x squared over 16. To differentiate this function, we use the power rule and the quotient rule. For the quotient rule, the formula is vu primes minus uv prime over v squared. So that f prime, we will get 1 over 4 x power of 3 over 4 minus x over 8. Then we identify the x naught. We choose 16 because it is near 15.98. Then delta x, we will get negative 0.02. Then we substitute all into the formula. We will get approximate negative 14 plus 63 over 1600. And the final answer is negative 13.961.
In conclusion, we can realize that maths plays a vital role in nature. As we use maths for everyday use, we have to make sure that we understand on how to apply maths in our life. Mathematics expresses itself everywhere, in most every facet of life in nature all around us. That's all from us. Thank you.